Okay, for the geometry review, you will be given the formulas that you need. So, for example, on number 1, it says find the sum of the measures of the interior angles of a convex 45 So remember, this tells you how many sides there are. So there are 45 sides. So we want to use this formula here, the sum of the interior angles. So we're going to say 45 minus 2 times 180. Put that in your calculator. We get 7740. Number 2, find the sum of the measures of the exterior angles of a convex 39 So remember, for exterior angles, when you add them all together, it will always be 360 degrees no matter how many sides there are. Number 3, if the measure of each interior angle, so be careful here, the measure of each interior angle of a regular polygon is 72, find the measure of each exterior angle. So if you have your interior and your exterior angle, they should always add. So if you have each interior angle is 72 degrees and you need to find the exterior angle, when you have an interior and an exterior angle, if I draw something like this, here's an interior and here's an exterior, they will add to be 180 degrees. So we can do 180 minus 72, which is 108. Okay, so on this part, you have to make sure you read extra carefully and see what it's giving you and what it's asking you. Number 4, if the measure of each interior angle, so one interior angle is 171, find the number of sides. So when you're finding the number of sides, you're finding n. So we're going to use this formula right here. So this formula is equal to one interior angle. Okay, so if we're given this, we need to find n. So we're going to set it up, n minus 2 times 180 divided by n equals 171. And we're going to solve for n. So first thing, we're going to multiply by n, so these n's cancel. So we have n minus 2 times 180 equals 171n. So we need to distribute the 180. So we get 180n minus 360 equals 171n. Now remember, we're just solving for n here. So I'm going to subtract 180n over. I have to go over here. So negative 360 degrees equals, oops, sorry, that's not right. Negative 9n. And we're going to divide by negative 9. So the number of sides is 40. Remember, if you get a negative number there, then you did something wrong because you're finding number of sides, and so it should always be a positive number. Number 5, which of the following is a property of all parallelograms? Each pair of opposite angles is congruent. Now, before we start reading these, remember, when we talked about this, we had our parallelograms. We had 1 through 6, our properties. And then we had rectangles. We had 2 properties there. For our rhombus, we had 3 properties, and then for our squares, everything is true. So we're looking for something that's true about parallelograms, and that way it's true about all of them. So on number 4, or D, there are 4 right angles. I know that that's not true for all parallelograms, because I could have something like this that doesn't have right angles. Each pair of opposite angles is congruent. Well, we know in a parallelogram that that's true, so that means it has to be true for all of the others. But let's go through the other ones. Only one pair of opposite sides is congruent. Well, that's not true because a parallelogram has 2, both sides are opposite, or sorry, both pairs of opposite sides are congruent. And C, each pair of opposite angles is supplementary, and that's not true. It's not each pair of opposite angles, it's the consecutive angles. So angles next to each other are supplementary. Number 6, If the slope of AB is 1/2, the slope of BC is -4. So let's draw a little parallelogram here. So A, B, C, D. Okay, so AB, the slope is 1/2. BC is -4. CD is 1/2. Find the slope of DA so that ABCD is a parallelogram. So in a parallelogram, remember both sides are parallel. So for parallel, we need the slopes to be the same. So this slope we also need to be -4. So DA, the slope needs to be -4. Number 7, determine whether the figure with the given vertices is a parallelogram by proving opposite sides congruent. So two different things here. If you're proving sides are parallel, you need to find the slope of those sides and they need to be the same. If you're proving sides are congruent, you need to use the distance formula. Okay, so let's first graph this. -7, -4, that's A, 5, there's B, C, and D. So there's our parallelogram. Now, since these are straight lines, I'm just going to count those and save some time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So down here I'll say DC equals 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. AB equals 12. So that's good. Those are the same. So now let's check AD. And again, I'm going to use the distance formula. And the distance formula is x2 minus x1 squared plus y2 minus y1 squared. So I have -5 minus -7 plus 6 minus -4. And plug that in and see what that equals. I got 11.2 for AD, and now we'll check BC. So 7 minus 5 squared plus 6 minus a -4 squared equals. Plug that in. So 7 minus 5 squared plus 6 minus -4 squared. And I got 10.2. So let me just double check we did that right. AD, I did -5 minus a -7, 6 minus a -4. And then BC, 7 minus 5, and then 6 minus -4. Okay, I double checked this one. I put that one in wrong. There we go. So by using the distance formula, you can show that both pairs of opposite sides are congruent. Okay, determine whether the following quadrilaterals are parallelograms. Justify your answer. So when we look at this parallelogram, we know that both pairs of opposite sides are congruent. So this one we're going to say yes. And the reason is both pairs of opposite sides are congruent. So remember, we know 6 things about parallelograms. We know 2 things about the sides, 2 things about the angles, and 2 things about the diagonals. Okay, and then the second picture, they have that this diagonal is equal to this one, and this diagonal is equal to this one. So the diagonals are bisecting each other. So this one would be yes. And we'll say diagonals bisect each other. The next part says list the 3 other ways quadrilaterals can be proven parallelograms. So again, we have 2 things about sides. We know this, both pairs of opposite sides are congruent. We also know both pairs of opposite sides are parallel. Okay, we know 2 things about the angles. So we know that angles, opposite angles, are congruent. And we know that consecutive angles are supplementary. So remember, consecutive means angles next to each other. So like on this picture below, this angle plus this angle will equal 180 degrees. So that's what consecutive means. Number 9, find x so that this quadrilateral is a parallelogram. So first thing, in our angles, remember opposite angles are congruent. So if that's 134, that's 134. If this is 46, then this has to be 46. Opposite angles are congruent. Number 10, which of the following is a property of all rectangles? Well, rectangles don't have 4 congruent sides. That would be rhombus or squares. Diagonals bisect the angles. That's a rhombus. Diagonals are perpendicular. That's a rhombus or a square. Same thing, this one's a rhombus or a square. 4 right angles. So that one would be true for all rectangles. And remember, that's also true for squares. Number 11, determine whether the quadrilateral is a parallelogram. So let's see what we're given. We're given that consecutive angles here, remember consecutive is next to each other, are the same angle. So we know that they cannot be the same because they have to be supplementary. Now these are supplementary and these are supplementary, but these are not supplementary. So we're going to say no, consecutive angles are congruent. And we want consecutive angles to be supplementary. Number 12, which of the following is true for all rectangles? So we only talked about 2 properties with rectangles. The first one is this down here, has 4 right angles. The second one, diagonals are perpendicular. That's for a rhombus and a square. So it's not that one. Diagonals bisect the angles. Nope, that's rhombus and square. The consecutive sides are congruent. So consecutive sides, meaning the sides next to each other, are the same. That's not true because that would be for a square or a rhombus. Consecutive sides are perpendicular. So these sides next to each other make a 90-degree angle. So that would be the answer. Number 13, quadrilateral ABCD is a rectangle. If DG equals 27, find AC. So we want to find that whole thing. So in a rectangle, we know that the diagonals still bisect each other. So if this is 27, this is 27, because that's a property of parallelograms. But in a rectangle, the diagonals are also equal to each other. So if this whole thing, if I add that together, 27 plus 27, I get 54. These 2 pieces are also 27, and so when I add that, I get that AC equals 54. In rhombus PQRS, if PQ is 11, find RS. So in a rhombus, all 4 of the sides are congruent. So if this is 11, then this one is also 11. In the same rhombus above, find angle POQ. So we want to find this angle here. So in a rhombus, the diagonals create 90-degree angles in the middle. So then angle, or the measure of angle POQ, is equal to 90 degrees. Number 16. In this rhombus, find the measure of angle 1. Okay, so the thing to remember about a rhombus is the diagonals bisect each other. And that's something you want to make sure you remember. Diagonals bisect, sorry, not each other. Diagonals bisect vertex angle. So if this is 22, this is 22. Okay, and then remember that these inside angles on a rhombus are 90 degrees. That's what we talked about up here. So if I know this is 22 and this is 90, I can find this angle. So I did 180 minus 22 minus 90, and I got 68. So this here is 68. And remember, this bisects that vertex angle, so it means angle 1 is also 68. Number 17. To prove that the diagonals of a rhombus are perpendicular to each other, you would position and label a rhombus on a coordinate plane and then find which of the following angles, or which of the following. So if we have a rhombus and we want to prove that these are 90-degree angles, if you're trying to prove 90 degrees, that means you're trying to prove they are perpendicular, which means you need the slope of the diagonals. That way we could prove that one slope is an opposite reciprocal of another slope. So remember, perpendicular, opposite, reciprocal. Number 18, use the square to find the following measures. AED. So we want to find this one right here. So in a square has the same properties as a rhombus. So the diagonals in the middle create 90-degree angles. EDA, so I want this one. Again, the same property as a rhombus. So the diagonal bisects the vertex angle, and since this is 90 degrees, I do 90 divided by 2, which is 45. Number 19, in trapezoid DEFG, find the measure of angle D. Okay, so number 19, we have a trapezoid now, so you have to be careful because you notice that there's different properties here. So 136 is not the same as 72, but because these are parallel, this angle and this angle are going to be supplementary, or this angle and this angle are supplementary. So these two, I'm going to do 180 minus 136, and I get 44. So angle D is 44. Number 20, for isosceles trapezoid PQRS, L and M are the midpoints. Okay, so if we know that these are the midpoints, that just means that this is congruent to this is congruent to this, and LM is the median. So they want us to find LM and the measure of angle R. Okay, so the median formula. Median is 1/2 times the top base plus the bottom base. Okay, so that's your formula. So if I want to find the median, I want to find LM, I'm going to do 1/2 times the top base, so 26, plus the bottom, 48. So LM equals 37. Okay, then we want to find the measure of angle R. So again, in a trapezoid, this line here, the top and the bottom are parallel, the bases. So that means this angle and this angle are supplementary. So I'm going to do 180 minus 57. And I get 123. So the measure of angle R equals 123. Number 21. For trapezoid, A and B are midpoints of the legs. Find ML. Okay. Okay, so again, if A and B are midpoints, that means that these are congruent. So AB is the median. Okay, so this is backwards from what we just did. Now they're giving you the median. So the median is AB. So we're going to say 36 equals 1/2 times the top base, which we don't know. So let's call it X, plus the bottom base, 32. We're going to solve for X. So this would be 36 equals, I'm going to distribute 1/2 X plus 16. Then I'm going to subtract the 16. So that will be 20 equals 1/2 X. And divide by 1/2. So X equals 40, or ML equals 40. Number 22, for isosceles trapezoid, find MNQ. MNQ. So we want to find this angle right here. So in an isosceles trapezoid, we know that the legs are congruent, and we know the base angles are congruent. So if this is 59, this is 59. Now they gave us this nice piece here that says this is 90, so that means the angle next to it is supplementary, so it's also 90. So we can say 59 plus 90 equals 149. And since we have this little triangle, we'll just subtract that. We get 31. So the measure of angle MNQ equals 31. Number 23, which of the following terms best describes the polygon? Let's count the sides first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we know it's not a heptagon. A heptagon is 7 sides. Then you have concave and convex. So the way to remember concave is it has caves in it. So these are inside, they're like caves. So this is a concave polygon. Number 24, draw quadrilateral ABCD. So let's draw a quadrilateral ABCD. It says AB is parallel to CD. So we know these two are parallel. Angle A is congruent to angle B. And AB does not equal CD. So this piece and this piece are not the same. Name the quadrilateral. So in a parallelogram, we know that we have the sides congruent. So here they're telling us that AB is not congruent to CD. So since it's not congruent, the only other one it can be is the trapezoid. And the last one, ABCD is a quadrilateral. Determine it's a trapezoid and justify your answer. So let's graph the coordinate points first. So there's A. There's B. C. Sorry, I almost started going the wrong way. All right, let's double check that. 8, -1, 10, -7. I went the wrong way. There we go. 1, 2, 3, 4, 5, 6, 7. -6, -1, and 0, 2. There we go. Okay. So there's our figure. So for a trapezoid, we need to know that this side and this side are parallel to each other. So let's check the slopes there. So we're going to check the slope of AD and of BC. So from D, I'll count 1, 2, 3. So that would be -3. 1, 2, 3, 4, 5, 6, 7, 8 over 8. And then we'll check BC. 1, 2, 3, 4, 5, 6, it looks like, negative 6 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, which reduces to negative 3 over 8. Okay, so because we found the same slopes, we know that AD is parallel to BC. So we have one pair of parallel sides, and so it's a trapezoid.